Alright, it's probably 88 merge sorted array. Easy difficulty if you're given two integer arrays, nums1 and nums2, that are sorted into integers m and n, representing the number of elements in num1 and nums2 respectively. Merge them into a single array. It should not be returned. Instead, it should be stored inside the array nums1. So to accommodate this, nums1 has length m plus n, where the first m elements denote the number of elements that should be merged, and the last n are set to 0 and should be ignored. Nums2 has length n. So here, got nums1, nums2 combined, merged, they equal this. See what the constraints are. So m plus n must be greater than or equal to 1, so they can't both be 0. It's possible for one of them to, and they can also have negative values. Okay. So the algorithm runs in O of m plus n time complexity. So looking at this example here, let's so first of all, this has three. M is 3, n is 3. So to make this less confusing, to prevent the threes from getting confused, let's just set this to be 4. Let's just set this like 1, 12, like 18, 20, and then 1, 2, 15, 16, and then, okay, let's do it like this. So we know the final result is going to have an extra 0 to accommodate these three numbers. So we know the final result should be like 1, 2, 12, 15, 16, 18, and 20. So how can we take these and then obtain this final result? So looking at this, and then looking at this, we can see that this 20 was obtained by, so we know that the zeros had to be overwritten, and then we also know that the 20 is bigger than any other element in nums2. So that's how we somehow got the 20 to be at the end there, whereas this 1 was kept in place. So what we could do is we can have like a pointer here that keeps track of, that's going to store the greater of the nums2 compared to the nums1. So here we can have like another index I. Here we can have another index j. So we can compare the nums1 of I is greater than nums2 of j. So that implies nums1 of k will equal to nums1 of I. And then we'll also, decrement the I and the k. So we basically just write the 20 here, then move the I over because it's already been considered. It's already been merged into this final array. So now we compare to 18 and 16. So again, the nums1 of I is greater than nums2 of j. So then we could set the 18 here. So k was here. So now there's this 18. So now we decrease the k and the I. So now here, the 16 is bigger than the 12. So now we got the opposite, where nums1 is less than nums2 of j. So then you're going to set this equal to nums2 of j, and the j gets decremented. So here we'll get this 16, decrease this k, and decrease this j. So even though there's this 20 here, it's already been written here, so we don't have to worry about, a duplicate 20. Okay, so basically now we compare the 15 and the 12. The 15 is bigger than the 12, so now we write the 15 here, decrease the j, and decrease the k. Here, 12 is bigger than 2, so put the 12 here, decrease both the I and the j. And write the 12, 15, 16, 18, 20, that matches what we have here. So now we just got to figure out what to do with this k. So the 2 is bigger than the 1, so you move the 2 here, decrease the j, so it's basically out of range. And then now the k is aligned with the I. So then because the j is out of range, you just set the nums k equals to the nums of I, and then the k is going to be out of range, and then they're done. So basically we're going to have 3 indices, I, j, and k. I is going to be equal to, it's going to be set here. So that's basically, it's going to be set here. The first, the last element that should be merged just before the 0 where it's going to store the new value. So basically this is going to be m minus 1. And then similarly, the j is going to be the last index of nums2, which is basically 3 minus 1, so n minus 1. And then k will be basically the last of nums1, and it has length n plus n, so it's going to be n plus n minus 1. So while k greater than equal to 0, you got this condition here. This, then we decreased k into j, or k into I. And then here, you have this, and this. And then since we don't want this to return the final sort array should not be returned by a function. Instead, it should be stored inside the nums array. So that's why we just return. We don't return the nums 1. So we got these. We can have like greater than or equal to. So we can handle the case in case where they're the same. But one issue here is what if I or j is negative? So we know that here when j was negative, we set the nums k to be the nums of I. So that's here. So basically we would have if j less than 0 or I greater than equal to 0 and this. And then this basically turns into an else because there's no other possibilities. All the other possibilities will be handled here. So it looks like that should be it. And it passes all test cases. So that's it. Thanks for watching.